Hey guys, it's Mrs. Decker. Today, what I'd like to do is review the triangle relationships that we have covered thus far. So if you kind of take a look here, we've done 3 different sections. So we're going to highlight each of those 3 sections here and then do some practice problems and make sure that we understand these properties before we move on to the last section. We only have one more section to go before we take our final test. So let's go ahead and get started. The first lesson was on these 2 angle theorems in a triangle. So we have the inside angles, and then sometimes we also have an outside angle that we have to consider. So first one, the interior angle theorem, just states that all 3 angles inside of a triangle must total 180 degrees. So let's write that down. And I would encourage you guys to write these down as well in words. All 3 angles are going to total 180 degrees. All 3 inside angles. So if we look at the example to the right, we have 3 of the interior angles written in terms of the variable b. So we don't know any of the 3 angles, but we can set up an equation that shows that if I add all 3 of those angles up, it has to equal 180. So my equation is going to look like b, the first angle, plus another angle, 2b, plus the last angle, b plus 16. And we know if we add those 3 angles together, it has to be equal to 180 degrees. So I've got an equation. Now all I have to do is solve the equation. First thing I'm going to do is simplify it a little bit. We've got lots of b's going on here. So all together we have 4 b's. Just add their coefficients. Bring down the plus 16 equal to 180. And then from here, I'm just going to isolate the variable. So I'm going to do a 2-step equation here, get the b by itself, subtract 16 to both sides. That will leave me with 180 take away 16 is going to be 164. And then last step, divide by 4. And so we get the solution of 41. And so if I wanted to, I could plug that back in to my triangle and find all 3 angles. So B is 41, so that means that top angle is going to be 41. The 2B angle, 2 times 41, that's 82. And then the last angle, 41 plus 16, is going to give me 57. And I can check by adding all of those up. And I better get 180. So 7, 8, 9, 10. Carry the 1, 10, 18. So that checked out. Okay, so interior angles, all 3 angles have to total 180. Set up your equation, get it equal to 180. Sometimes you have some like terms that you could combine and simplify your equation before you start getting that variable by itself and solving for it. Second up is the exterior angle theorem. And honestly, guys, you don't even need a theorem. You can just use 2 properties, one being every straight line is 180 degrees, and all the angles inside of a triangle have to total 180. So you really don't have to use this theorem, but it's going to save you some time. It's going to save you some steps if you do know the property, which is that the 2 inside angles is going to equal the outside angle. So 2 inside I don't have my good stylus. It's not being very nice right now. 2 inside angles is going to equals the outside. But again, you really don't need this. You could just simply do 180 minus the 147. That's going to give you 33. So you know this angle inside the triangle is going to be a 33-degree angle. You could add up the two angles now, 42 and 33 inside the triangle. That's going to give me 75. And I got to get to 180, so subtract from 180, and you get 105. And so I would know D would be 105. But if you know the property, let me do this in red, then you just know that the outside angles, these two have to add up to give you the 147. So I could do 42 plus D equals 147, and then subtract 42 from both sides, and that'll give me the same answer of 105. All right, so that was our first section, focusing on the angles, inside angles and outside angles. Then we moved on to the two special triangles, isosceles and equilateral. So isosceles, remember the way I remember it is we all have two eyes, and so isosceles has two equal sides. And so to show in a picture that we have two equal sides, they use those tick marks. So if I look at this example, I've got these little tick marks. So that means that those are the two sides that are equal. That last third side is not equal to those two. But because those two sides are equal, that also tells us that we have two equal angles, and those angles are going to be across from the equal sides. So if I notice that 54 is an angle, and it is directly across from that equal side, so then the angle that's opposite of the other equal side, that has to also be 54 degrees, because those are my two equal angles. And if I want to find the last one, let's add up and see what we've got so far. So we have those two 54-degree angles. That's going to give me 108 degrees, but I need to get to 180 since I'm inside of a triangle. So I subtract from 180, and I get 72 degrees as my final answer. Okay, so isosceles, two eyes, two equal sides, two equal angles. Just go across from those sides to determine which two angles are equal. Sometimes they'll actually give you the one that's not equal, so the 72 in this case. And so you'll have to subtract from the 180 to see what's left over, and then just divide by 2 since you have two unknown angles remaining. So there's kind of another strategy there, depending on what the problem gives you to begin with. And then equilateral triangles, equal, everything's equal. So all sides are equal. They're all the same length. So they're all like 5 inches around or whatnot. And then because all sides are equal, that means all angles are equal. And if all angles are equal, dividing the 180 by 3 is going to give me 60 degrees. So I know that every single equilateral triangle, no matter if it's 23 inches around or 59 inches around, all of the angles are always going to be 60 degrees. But this example deals with the sides since I'm outside the triangle. So 5y minus 6 is one of the sides, and 4y plus 12 is the other side. And because all of these angles are marked equal, then I know all the angles are equal, that means all my sides are equal. And so this is an equilateral triangle. And so my equation is I'm gonna set both of those things equal to each other. I'm not gonna add them together because I don't know their total, but I do know that they have to be the same. So I'm going to set those up equal, and notice our technique is going to change to solve this equation just a little bit, because if I draw that line down the equal side sign, I notice I've got y's on both sides. So I've got to get rid of them. I've got to take them away on one side to get them all on the same side. So I'm going to take away the 4y to both sides. So I got rid of them on the right. All I've got left is 12. And then over here on the left, I started with 5. I took 4 away, so I only have 1 left. Minus the 6, bring that down. And then now I can just add 6. And I'll have y by itself, and it'll be 18. I could also plug that back in, so I can notice, oh, well, now I know y is 15, so I can figure out how long it is from point P to point O by just plugging that 18 back in. So 4 times 18 plus 12. So 4 times 8 is 32. Carry the 3. So that's 72. Plus the other 12. That was part of the equation. That's going to give me 84. So all of the sides would be 84 units long. All the way around. Even if I plugged it in for NO, this is the cool part. Check your answer. If I plug 18 is still y, but I'm going to do 5 times 18 minus 6. So 5 times 8 is 40. That's 90. Take away 6. Does that give me 84? It does. And so I just verified that those sides come out to be the same because it's an equilateral triangle. All right, so those were those two special triangles. Isosceles, 2 of them are equal. Equilateral, everything's equal. Okay, then we had the triangle inequality theorem. That's what we left off with last week. So we had 2 kinds of problems. So we're kind of switching gears to sides now. And we're thinking about, okay, if I had a 12-inch side, a 4-inch side, and a 17-inch side, is that even going to make a triangle? Because it may, and it may not make a triangle. So what you're going to do is you're going to first find your 2 smallest sides. Out of those 3 numbers, which 2 numbers are the smallest? Well, 12 and 4. 12 and 4 are the 2 shortest sides, 17 being the largest. So I'm going to add those up. 12 plus 4, that gives me 16. And what I get must be bigger than that last side. So 16 is not bigger. It's not bigger than 17. So that means no, this is not a triangle. I cannot make a triangle out of those 3 lengths. So all you got to do, add the 2 smallest numbers. If it's bigger, then it's a triangle. If it's not, then it's not a triangle. The other thing that we can use this theorem for is to figure out, well, if 2 sides have to be this long, what could that 3rd side be? So this is a 2-stepper because you want to find what's the smallest it could be and then what's the biggest it could be. So find the smallest by subtracting. 8 take away 5 is 3. And then find the largest by just adding. 8 plus 5. I was getting ready to write 13, the answer. 8 plus 5 is 13. So the 3rd side must be between 3 and 13 units long. Otherwise, it's not going to make a triangle. And just a kind of side note, it has to be strictly bigger than 3, so it couldn't equal 3, because then it wouldn't be bigger than 8. So it would have to be like 3.1, and then it has to be strictly less than 13, so like 12.9. It has to be strictly between those numbers. It can't equal. All right, and then the last thing I just wanted to go over quickly with you guys, I know we have studied it a few times throughout our semester together, so I hope that this is like really, really hitting home with you guys, and this is something that you can remember for a long time, and that's the Pythagorean theorem. It works for any right triangle to figure out the lengths of the sides. So remember, it states that if I multiply the legs by themselves and then add them together, so legs squared plus legs squared, that has to equal the hypotenuse squared. Okay, and let's maybe draw, let's see, where can I fit in a right triangle here? So just to review, we got a right triangle, got that 90-degree angle, so the sides that make that, those are your legs. I'm going to put L's for legs. And then the one across from the right angle is the hypotenuse. Okay, so hypotenuse is the most important one. You got to get it right. So that's the one that I always identify first. So if we're looking at this first example, 21, that is my hypotenuse. And so the other two are my legs. So I'm just going to do x squared plus 8 squared must equal 21 squared. And so we're going to simplify this. Go ahead and square the numbers. So 8 times 8, 64. And 21 times 21 is going to be 441. And now we can work to get the x by itself. So 2 steps here. We're going to subtract the 64. And that's going to give me 377. And then last step, everybody wants to say divide by 2. But it's not divide by 2. Remember that opposite operation of a power is the root. So always last step in Pythagorean theorem, you've got to have a root. The square root of 377 would be my final answer. Okay, so identify that hypotenuse. Make sure you get it by itself on the one side. And then you may subtract and root it, or you may add and root it, just depending again on what is given. But it's always going to be those 2 steps to solve. Always remember to square root at the end. That's always what gets left out. And then the last thing we can use Pythagorean theorem for is to determine if it is a right triangle. And if it's not a right triangle, then is it acute or obtuse? So again, most important thing is the hypotenuse. It's the largest side. So out of these 3 sides, 16 is the hypotenuse. So I'm going to go ahead and do that hypotenuse squared. So 16 squared, that is 256. And then I'm going to do the leg squared plus the leg squared. So 9.6 squared plus 12.8 squared. And I definitely used a calculator because they are decimals, but you get 92.16 plus 163.54. And if you add those together, you get exactly 256. So, hey, notice I got the same thing. And so if that happens, it's a right triangle. If your hypotenuse squared was larger, then it would be obtuse. So if h squared is bigger than L squared plus L squared, that's obtuse. And then if h squared is less than the leg squared plus the leg squared, that is acute. So that could happen. All right. Okay, hopefully that was a nice quick refresher over what we've covered so far in the triangle relationship module. I hope that you can go through those practice problems and have success with it. There are some retakes available, so if you make a mistake and you want to go back and fix it, I encourage you to do that. And as always, please let me know if you have any questions. Hope you guys have a good day.